In this video, let's start by just reviewing how do we reduce an answer when it's in this form. So the first thing I'm going to do is I'm going to ask myself, is there a perfect square that divides into 28? And I do want to choose the largest perfect square. 4 is the largest perfect square that does divide into 28. Now the square root of 4 is 2. This 8 underneath does need to be reduced with both the left and the right. So I want to see, can I reduce these three numbers by a specific quantity? Each of them are even. I'll divide by 2 to get 4, divide by 2 to get 1, divide by 2 to get 4. Let's look at example number 2. What is the largest perfect square that divides into 32? That'd be 16. So the square root of 16 is 4. And now I'm focused once again on these three specific values. They're all divisible by 2. Divide by 2, divide by 2, and divide by 2. Our last one. What is the largest perfect square that divides nicely into 27? And that would be 9 times 3. The square root of 9 is 3. Okay, and now I'm focused on the three values that are underlined. What is the largest number that divides into each of those? It would be 3. Divided by 3, divided by 3, and divided by 3. Okay, let's go down below. And let's review how can we solve this using the completing the square method. So for completing the square, remember there's a couple shortcuts we can do to doing this. So the first thing is I'm going to take whatever this constant is, I'm going to move it to the opposite side. Then I'm going to take the b value and I'm going to divide it by 2 and then I'll square it. So when it divides by 2, it's -6, and when I square it, I get a positive 36. So I'm adding 36 to both the left and to the right to keep the equation balanced. Now I could ask you to come off to the side and to factor this, but the shortcut is take whatever this is and put an x right there in front. So x minus 6, quantity squared. Adding together, I end up with 6. Remember, my whole goal is to solve for x, to make this mathematical statement true. To isolate the x and to square both sides, remember this does tell me that I'm going to have two answers. On the opposite side, I do a plus or minus, in this case, square root of 6. Then I add 6 to the opposite side, it goes in front. X equals 6 plus or minus the square root of 6. This 6 cannot be broken down any further, and I have my final answer. These represent the two solutions or roots or x-intercepts or zeros to this if I was going to graph this y equals. Now just solving it as an equation, again, these are the two x answers. If I plug these in for x, I'd come up with 0 equals 0 as an answer. Okay, so it'd be a true mathematical statement. Let's look at our next one. Again, let's start by moving this to the opposite side. So I have x squared plus 6x. Now when I move 10 over, I'm going to add it. I end up with 10. I take whatever that b value is. I take the b plus the sign. I divide by 2 and square it. 6 divided by 2 is 3. I square 3 to end up with 9. Whatever I add to the right, I must add to the left. So I could tell you, go ahead, go off the side and factor this. Or the shortcut is just take this, put an x in front of the symbol, in this case a plus sign, and 10 plus 9 is 19. We're going to have two answers. X plus 3 equals plus or minus the square root of 19. And now moving 3 to the opposite side, I get x equals -3 plus or minus the square root of 19. This cannot be broken down any further, and we're good. Now what happens if you have a number in front? I'm still giving you a pretty one to do here. So the first thing I'm going to do is I'm going to factor out this x, or the 8 number in front. So 8 times 1 is 8 with an x squared. 8 times -5 is -40. I'm going to move this to the other side. And when the 24 moves over, it becomes a -24. So again, I moved the 24 over, and then I figured out what goes here. Now I'm only going to be focused on this number in the middle. Oh no, I got a -5. So I have -5 divided by 2. I can't reduce that any further. We don't write this as a mixed number, and now I need to square it. Remember, when you square it, it means writing it twice. So in this case, I'm going to take -5 times -5. I'm adding 25, and 2 times 2 is 4. Now, I didn't just add 25 over 4 to the left. Remember, I have to take 8 times that quantity. 8 times 25 over 4. That's the quantity I need to add to the right-hand side to keep the two sides balanced. So I can reduce this. 2 times 25 is 50. So if I took 8 times 25 over 4, we'd see that it just equals 50. So if I took 8 times 25 divided by 4, we can see it's the same thing as 50. So I added 50 to the left. I need to add 50 to the right. Now the equation is balanced. Inside, I take whatever was here, and I write it down again. That's my shortcut. On the right-hand side, when I subtract 24 from 50, I end up with 26. Dividing by 8, I have x minus 5 halves squared equals 26 over 8. Excuse me. Okay, this tells me I'm going to have two answers. Take the square root, x minus 5 halves. Now I'm going to break this apart. I have 26 over 8. Okay, so what is the fastest way to go about doing this? So neither of those are perfect squares, but let's see, is there a perfect square that divides into them? So I know that if I take this times the square root of 8, and I maybe should have done it a different way, I'm going to grab a calculator and go 26 times 8, and I get 208. So on top I have 208. 8 is just by itself from the bottom. And now I need to work to see, can I reduce the radical on top? So I'm going to go through the perfect squares that I know, and I'm going to start to divide. Oh, sorry, divide. And I'm dividing, that doesn't work, 14 times 14, okay. Oops, 208 divided by 196, that doesn't work. So that's 13 times 13, that doesn't work. And 208 divided by 11 times 11. No, I know it's not going to be divisible by 100, and I just keep going down the list. Let's see, can we break this apart? So you can see this was 13 times 13, 12 times 12, 11 times 11. You have that paper that you can take out that was provided to you, where it has the perfect squares and the perfect cubes. 10 times 10, 9 times 9. I'm just working my way down. So I'm on to 8 times 8. Nope, I'm getting maybe close here. 7 times 7, 6 times 6. 5 times 5, 4 times 4. Oh, there we go. Okay, so 2/8 breaks into 16 and 13. Is this essential? Yes, it is. So 16 and 13, that's the largest perfect square that does go into it. The square root of 16 is 4. To period 6. Okay, so I know that 4 and 8 reduce to 1 over 2. So I have 1 square root of 13 over 2. You don't have to put the 1 out front if you don't want to. And remember, if I come back up here, I'm going to have two answers, so plus or minus. And my last step is to move the negative 5 halves to the opposite side. When it moves over, I add. And these would be my two answers. You can put a 1 in front if you want to, but it's not necessary. It's important you do know how to do this problem as well.